Once again, good morning everyone. I would invite Arun sir to start the session.
Thank you, ma'am. Hi, students. Good morning, everyone.
Good morning, sir.
Hello. Hi.
Good morning, sir.
Hi, Bhavna. Good morning. Bhavna, you missed the Saturday's class. Why did you miss the Saturday's class?
What, sir?
You missed Saturday's class, right? Why did you miss Saturday's class?
Network problem, sir. There was.
Oh, did you attend the recorded session?
No, sir.
Oh, that's very important. I mean, BX graph and AX graph I discussed. Right? That's very important. All right. So before we continue, there is
I
one
will
graph
attend,
from
sir.
prepare. Sorry?
I will attend, sir, that class.
Yeah, please attend. If you don't have a doubt, please ask. And there is one graph left in the paper. I would like to discuss that. Then we'll go for motion to gravity graph. We are still at NEET and mains level. We haven't reached advanced level. Problems is of advanced level. We haven't reached there. We'll soon we split the class of NEET and IIT, and then we'll go for advanced level. Okay, the acceleration diagram of a particle moving in a straight line is that one in picture. The velocity of the particle is 2 meters per second at t equal to 0. The velocity after 2 seconds will be. All right, it's a good question. 80 graph. He says, what is the velocity at two speeds? Initial velocity is given as not 0 but 2 meters per second. So I need to find area. Area gives me delta V. Delta V. So V minus V naught is nothing but area under the graph. So V is equal to V naught plus. I need to write bigger, which I remember. V naught plus area under the graph. Alright, so what is V naught? 2 meters per second. Now area under the graph is what we have to find out. How do I find? I've got triangle and a trapezium. But in trapezium, the height is not known. How do I get to know this height from this triangle? 4 by 2 is equal to x by 1. Let's say this question mark. This is 4. And 1 to 3 so 2 seconds. So 4 by 2 is question mark by 1. So question mark is equal to 2. Do you agree with that?
Yes, sir.
Alright, good. Hi, Fred, good morning.
Good morning, sir.
We will soon split the class for IT and NEET. Alright, now we are at the NEET and mains level. We are at NEET level basically. So once we split the class, we can go for advanced and only for NEET. Alright.
Okay, sir.
But the concepts are same. Only thing is application is a little tricky in mains and advanced. Alright. So I got this trapezium. What is the area of this trapezium? Half times sum of the sides, which is 4 plus 2 into 15 now. So then it's x by 2, which is 3. What is the area of this triangle? Two.
2, sir.
Yeah. So what's the total area?
5, sir. 3 plus 2, 5.
So you got so V is equal to 2 plus 5, which is 7. 7 seconds is my velocity at the end of 2 seconds. Alright? That's how we do it. But AX graph and VX graph are very important for exam. We have dealt with that AX graph and VX graph on Saturday's class. On Saturday, we discussed AX and VX graph. We haven't done many problems in that. But we will do some problems eventually whenever we come across some situation on AX and VX graphs. Alright, now let us go for another graph which will introduce us to motion to gravity. Through graph, we will be introduced to motion to gravity. Motion to gravity is very simple. It's nothing but motion at a constant acceleration of t, which is directed downwards always. So, if a particle is projected upwards with a velocity v naught, g acting downwards, what happens to the particle? It goes up, its velocity decreasing, length of the arrow decreasing, it stops momentarily, then reverses in direction. Alright? That's what happens. Now, that's what's physical analysis. A particle goes up, stops momentarily, returns, and in the return journey will require the same speed as launch speed. Speed with which you have reached, it requires the same speed. How and why we'll see. But this is what we know from intuitively, we know this about the physical situation. Particle is projected upward, its velocity goes on decreasing, it becomes zero momentarily, but its acceleration is still there. It gets accelerated downward now. After that, in return speed, it gets accelerated downward. It accelerates. In both cases, the acceleration is g, downwards. If I take upward as positive, downward as negative, and if I plot the graph of VT graph, let's see what initial velocity is V naught. I'm plotting VT because VT is more informative. Alright. So it is correct because the particle is taking a turn. VT graph is linear because the acceleration is constant. Alright. But I told you we should plot a graph only after I have an equation. What is the equation I've got? V is equal to u plus at. U plus at. What is u? V naught. What is a minus g? V is equal to v naught minus gt is my equation. How do I plot this? Y is equal to mx plus c. Slope intercept form, or the ones who are not attending that session, Neet students. How do we plot this? I've got y is equal to mx. Y is equal to minus mx plus v naught. That's how I plot it. So I've got y is equal to x like this. Y is equal to minus x like this. Minus gx minus gt. Then I put it out at v naught next. So this passes through v naught. V naught comma the 0 comma v naught. You all agree with this? All I did was I've written v is equal to u plus at. U is v naught plus v naught because it's projected upward and upward is taken as positive. and acceleration is minus g. Why? It's actually happening backwards, so it's negative g. So v naught minus g is now velocity as a function of time. Now this I have to plot, but this one I don't plot it this way. It's not continuous straight line like this. Why is it not a continuous straight line? Because after a certain time, when it goes up and comes back, when it hits the ground, it again goes down. Let's say there is no loss of energy. It continuously goes up and down, goes up and down. Ideally, the most ideal case, which is not practical case, it goes up and down. Right? Okay. So I have plotted V equal to minus GT like this. Minus GT plus V naught. Or y is equal to mx plus c is a slope into the form. Slope is minus g and intercept is V naught. Minus g is V naught. Both mean the same thing. Alright? Now, this point, how to at ground? How can you say that from graph? It started from ground at this point t equal to 0. This area is equal to this area. So it's at ground again. Displacement is 0. It started from 0, displacement. It's again went up, came back in the same position. So displacement is 0. So area under the graph will be 0. So positive area, so negative area. So we can cancel out, we get displacement is 0. Alright? I am studying. I have drawn the graph only for one to and from motion. It went up and came down. But when it bounce, again go up, come down. Bounce, go up, come down. Bounce, go up, come down. This happens forever. Now, because it happens forever, and that is periodic motion. The motion is periodic. That means that you can have a periodic interval of some time t. My graph will also be periodic. That means my graph is not just this, but it should be periodic now throughout t, throughout till infinity. Is it clear? Do you all understand what I mean to say? This motion is periodic. It is going up and down forever. So my graph will also be periodic. Okay, because graph will reflect what is happening in the physical situation. If the movement is periodic, but graph will still be periodic. Whatever is occurring in the motion, that should be reflected in the graph. For instance, my acceleration is constant. My VT graph is linear. My acceleration is constant, which is minus t. Initial velocity is v naught. Final speed is also v naught, but negative velocity. It's oppositely directed. After that time t, capital T, it goes up and comes down capital let's say t naught. This total time is t naught. So it stops at t naught by 2 and comes back at t naught. Displacement is 0. Area under the VT graph is 0. Let us find out what time that is. When does the particle become 0 or come to length? When the velocity becomes 0. That means my V naught minus GT is equal to 0. That is T is equal to V naught by G. It is becoming 0, right? V naught by G. Right? And when is the velocity becoming negative? Minus V naught. I equate this to minus V naught. So what do I get? So T naught is equal to 2 V naught by G. So this T naught is 2 V naught by G. So look at this, motion is symmetric. It is going up in time. It is going up for a time of V naught by G, and down within a time of V naught by G. Okay, so at V naught by G, it's taking a turn. That's what the graph is, and that's what is happening in the motion. పైకి వెళ్ళి ఆగుతుంది మరి తిరిగి మళ్ళీ వెనక్కి వస్తుంది ఆగుతున్న టైం ఏంటి ఎంత వచ్చింది నాకు వెలాసిటీ ఈక్వల్ టు జీరో చేశారు మరి ఈక్వల్ టు జీరో v naught minus gt equal to 0 I get t equal to v naught by g. That's when the particle is taking a turn because having to momentarily at rest. Alright. Next, when it hits again, velocity is negative, suddenly becomes positive. From minus v naught to v naught, it suddenly becomes positive. What is actually happening? It gets compensated stops, and then speeding comes. So this velocity over here suddenly comes to V naught. Again, the graph repeats. Do you understand the second graph? I have not drawn the equation of line, but yet I have plotted the graph. How did I plot the graph? Because this jumps to V naught, and the same motion repeats. So same line, same linear equation, same linear pattern, same linear sketch is repeated at this point of time. At 2 V naught by G, we write the equation for this as well, but without it first I've written the equation for this and plotted V naught VT graph. Then what I analyzed that after hitting for the first bounce, on the first bounce from minus V naught to V naught, velocity jump from minus V naught to V naught, velocity jump from minus V naught to plus V naught, and then this motion, upward motion is again same as the previous upward motion. So that means my VT graph should be structure of the VT graph should be same, which is linear and exactly same, and should be like this. And why is it parallel? Slope of VT graph is same because acceleration is same there. Omkar, I remember your doubt. I'll clarify your doubt at the end. All right. Your reference doubt you had a doubt. Question number 7 you had a doubt. Correct? Okay. All right. So I repeat the argument. First line I have drawn it using equation v is equal to v naught minus dt. Y is equal to mx plus c. All right. And then yeah, Bhavana, what is that you are asking? What is the angle for minus g? Minus g is downward. That's it. And this slope of this theta is my minus g. Alright, slope of this angle, sorry, slope of the line is minus g. So tan of this angle is g, minus g, negative g. Of this angle, na? So negative slope. Retardation. There is lot to speak on this graph. If you understand this graph carefully, you can solve almost every problem on motion of the gravity PT graphs. Alright, displacement, time of flight, two balls dropped at the same instant, from different heights. All such problems we will be able to solve. There is one previous Olympiad problem which I want to target tomorrow, not today. Today we'll understand this VT graph thoroughly and we'll target a previous Olympiad problem tomorrow, which is very important for both NEET and advanced. Alright, concept wise is very important for both NEET and advanced. But once we split the class, we can go for advanced specifically and NEET specifically. Alright, so don't worry about it. Alright, I repeat the argument. I repeat the argument. First line for the first upward motion and then downward motion. First to and from motion. We plotted using V naught, V is equal to V naught minus GT. Right. Y is equal to mx plus c. I plotted this line. This line says this particle is taking a turn at this point, and that's what is actually happening up there. This particle is taking a turn at highest topmost point, where the particle is coming at rest momentarily. Velocity is becoming zero momentarily over there. So that makes sense. When it comes back to this point, its displacement is zero. Areas are equal, so that makes sense. So this length should be equal to this length. That makes sense. But how do I find out this length? I equate the velocity to zero. When I equate this to zero, I get that time as V naught by G. Alright? This time is called time of ascent. TA or time of ascent. Because it's going upward. Look at this graph is coming downward, this particle is going upward. I told you VT graph difficult to visualize. But more information is written in VT graph. Velocity is decreasing, but velocity is positive. It becomes zero, then it becomes negative. So particle is going up, it's coming down here. Between V naught and V naught, particle is going up. Between 0 to minus V naught, particle is coming down. Alright? Now, after the first bounce, where is the bounce taking place? At 2V by G. At this point, the bounce is taking place. And after bounce, my motion after bounce is same as motion before bounce. One to and from motion, this motion from here to here is same again after from here to here. So I can just replicate this curve and paste it here. Replicate this line, paste it here. I'll get the most equation. Graph for the BD graph for the motion to first bounce. We'll write the equation in a way, but this is my motion after first bounce. Now let me know what is this point. What is this point, students? What is this point? Tell me something. What is this point?
3V0G.
Who is that?
Shravani sir.
Hi, Shravani.
Hello sir.
Yeah, check. Shravani, are you upset with something? You gave a
Sir,
very good answer.
thank you sir.
Okay. Be energetic, Shravani. You are giving a very good answer. Be energetic.
Okay sir.
Okay. Seems like I'm forcing you to be energetic. Okay. Anyway, that's a correct answer. C V naught by G. How can I say that? Because from 2 V naught by G to here, this is V naught by G. I'm just replicating this here. So 2 V naught by G plus V naught by G, which is 3 V naught by G. When will the second bounce happen? Hello, students. When will the second bounce happen?
4V0/3 by
4V0 by
G.
G.
Yeah, who is that? Two students answered.
Omkar V
Shravani
not
sir.
Yeah, Omkar. What is that you said?
4V0/G.
It's perfect. And Shravani, you answered, right?
Yes sir.
Ah, that's right. 4 V naught by G. Excellent. How can I say that? By symmetry. This is equal to this is equal to this is equal to this. Now, when is the second bounce taking place? 4 V naught by G. After second bounce, how will the graph be? Again, this my velocity goes up, becomes plus V naught. Again, same thing repeats. Right? 5 V naught by G, 6 V naught by G, 7 V naught by G, 8 V naught by G, and so on. That happens forever. And why are the lines parallel? What does the slope depict in a VT graph? What does it signify?
Area equals.
No, slope of VT graph is acceleration. And my acceleration is constant G throughout the motion except when collision. Except when this colliding, the particle is bouncing, except at that moment, my acceleration is G. Right? Minus G, downward, G downward. And that's why negative slope and all parallel lines. You cannot have a VT graph like this for a motion to gravity, you cannot have a graph like this. They have to be parallel. If they are not parallel, the graph is wrong. Alright? Why do they have to be parallel? Because my acceleration is same, which is minus v throughout the motion, except when collision. What happens when collision? We'll talk in a while. But without, apart from collision, apart from the time instant of collision, my acceleration is negative g downwards throughout the motion, except when collision. Alright? Except at the time of bounce, at the instant of bouncing, acceleration is not g, it is something else. But throughout the motion, except at the time of at the instant of collision, it is g down. Now, when it's one time, you have to tell me the particle is going up or down. Alright? Uh, here, at this time, at this instant of motion, is particle going up or coming down?
Moving up, sir.
Moving up. Shy. Are you sure, Bhavna?
It's
Yes,
coming down, sir.
Omkar is coming down. Why is it coming down? Why is it going up?
sir. It is not taken turn, sir. It is going up with less velocity.
Right. Omkar, it is V naught. But it is less than V naught. కానీ V naught పాజిటివ్ వెలాసిటీ పాజిటివ్ ఉంది ఇక్కడ. ఈ టైం ఇన్స్టెంట్ వెలాసిటీ పాజిటివ్ ఉంది. అంటే వెలాసిటీ పాజిటివ్ అంటే అక్కడ ఉంది. అప్పుడు I'm taking it as positive. Right? So its particle is going up. At this instant of motion, what is happening to the particle? At V naught by G.
It stops, sir. It stops there. Or it bounce,
Go ahead.
bounce. It will
Acceleration
bounce.
changes.
Yeah, direction changes. Someone said that and it stops there. That's right. It's not a bounce. Bounce అయితే ఏమవుతుంది? సడన్ వెలాసిటీ చేంజ్ అవుతుంది చూడండి. నెగటివ్ టు పాజిటివ్ అవుతుంది సడన్ చేంజ్. హిట్ అవుతుంది. హిట్ అవ్వగానే రీబౌండ్ అవుతుంది. So there is a sudden change in velocity. Sudden is a went down. Change in velocity. We are not wind. There is a quick change in velocity. మరి ఇక్కడ ఏమవుతుంది? V0 to 0 అవుతుంది. మరి నెగటివ్ అవుతుంది. So there is particle slow for moment. There is a movement in slow.
Yes, sir.
That's what it meant. I understood. All right. Now, there is a particle at this instant of time. Going up or coming down?
Down, sir. Coming down.
Down. Omkar, Ashita, Ifra.
Velocity is negative, sir.
Velocity is negative. So it's coming down. Omkar, Bhavna says it's negative, it's coming down. Shravani,
It's coming back and going again up, sir.
center of time. ఈ ఇన్సిడెంట్ దగ్గర ఈ పర్టికులర్ ఇన్సిడెంట్ దగ్గర వాటి కిందకి వెళ్తుందా వెళ్తుందా ఆ మోషన్
Sir, can you mark where the line up to?
this line this instant of time ఈ ఇన్సిడెంట్ ఆఫ్ టైం దగ్గర my particle is going up
Coming
or
down,
coming down.
sir, it is. It
Sorry?
have
What?
taken turn, sir, at
Yeah, it was already taken down at V naught by G.
and it is coming down, sir. Taken
Coming
turn and
down. Right. Shravani, do you understand that it's coming down? చూడండి velocity negative ఉంది ఇక్కడ.
Okay, sure.
So velocity negative, that means it's coming down. Negative ఉంది. If I ask you what is it at this position, at this instant of time,
it is also
Coming down, sir.
coming down,
yes,
sir.
coming down. Good. At this instant of time,
Going up, sir.
what is happening at 2v by g, 4v by g? 2v naught by g and 4v naught g. What is happening here?
Going up, sir. Particle is going up.
Now at 2v naught by g, at 4v naught by g, what is happening?
Particle is going up.
No. E line
Particle
path. At 2v
changing
naught by g. Yeah,
direction.
so there's a bounce. There's a bounce there. At 2v naught by g, there's a bounce. 4v naught by g, there's a bounce. Particle is bouncing at time instant. Alright.
Yes, sir.
ఇప్పుడు బికాస్ అనుకున్నా యూ వెళ్ళి ఎగ్జామ్ చేస్తాను ఈ గ్రాఫ్ అని కొడుతుంది కదా ఏది కరెక్ట్ చెప్పండి ఇంకా డిఫరెన్స్ ఎందుకు వచ్చింది కూడా చెప్పండి ఈ గ్రాఫ్ డిఫరెన్స్ ఉంటుంది ఆ డిఫరెన్స్ ఏంటి ఈజీ కనబడుతుంది బట్ డిఫరెన్స్ ఎందుకు వచ్చింది చెప్పండి
Because the particle is moving from downwards to upward.
V naught sorry minus V naught this is dt graph and this is again V naught by G so it's 2V naught by G this is 3V naught by G 4V naught by G and so on. What is it?
Particle is
Moving from downwards to upwards.
Coming downwards, sir, from upward to downward.
First tell me acceleration positive or negative?
Positive, sir.
Okay, if that is positive, what does it mean? My downward is taken as positive.
Yes.
Positive, sir.
Yeah,
Downward.
right? Downward is positive.
Yes.
That means upward is negative.
Yes, sir.
That means it's negative velocity at 90.
Going upwards.
Going upwards.
Right. Who is that? Bhaskar or Omkar?
Umar, sir.
Who is it?
Umar.
Let me just check. Umar. Okay. Hi. Hi, Umar. Mohammed Umar Farooq, no?
Yes, sir.
Yeah. That's right. It's going up. Both the graphs are same, identical. For that same motion, I've run the graph, but the only thing is convention reversed. అప్వర్డ్ పాజిటివ్ ఇంత ముందు తీసుకున్నా ఇప్పుడేమో అప్వర్డ్ నెగటివ్ తీసుకున్నా డౌన్ పాజిటివ్ తీసుకున్నా జస్ట్ గ్రాఫ్ ఫ్లిప్ అయిపోయింది ఇంత ముందు గ్రాఫ్ ఇలా ఉంది కదా ఇప్పుడు గ్రాఫ్ ఫ్లిప్ అయిపోయింది బట్ యూజువల్లీ సేమ్ సో could you conclude that because acceleration have taken as positive down to positive different negative and it is minus v naught it will be minus v naught then it goes upward v naught v naught నెగటివ్ ఉంది ఇక్కడ ఆగుతుంది మళ్ళీ వెనక వస్తుంది v naught హీట్ అవుతుంది పొజిషన్ అవుతుంది మళ్ళీ నెగటివ్ అయింది సో లెట్ మీ at this instant of time particle is going up or down
Upwards.
right that's
Yes,
upward
sir. The
at
particle
different
is
center time
going
Downwards.
Coming downwards.
downwards.
how can you say that because velocity is positive and the
Yeah.
positive is downwards then positive down direction kind of gravity is downwards slope is positive so positive downwards gravity is downwards so positive ఉంది that means gravity is positive downwards is positive upward is negative and this is the time of velocity positive on the downward particle is coming down right okay now let us do one thing let us say there is some loss of energy ఇక్కడ you usually observe if I drop a ball for the first bounce it might come to some extent second bounce తర్వాత ఆ extent వరకు రాదు కొంచెం తగ్గుతుంది కదా height
Yes, sir.
Yes, sir.
థర్డ్ bounce తర్వాత ఇంకో కొంచెం తగ్గిపోతుంది కదా height
Yes,
Yes,
sir.
sir.
అంటే ఎందుకు ఎనర్జీ లాస్ అవుతుంది you will be hearing a sound tuck tuck or you heat is released some energy loss అంటే క్షీణించిపోయింది కరెంట్ ఎనర్జీ క్షీణించిపోయిందంటే స్పీడ్ హెస్ డ్రాప్ after collision v naught తో హీట్ అయితే v naught by 2 తో అప్పుడు అనుకుంటాము ఓకే మళ్ళీ పైకి వెళ్ళి మళ్ళీ కిందకు వస్తుంది కదా v naught by 2 తో హీట్ అవుతుంది మళ్ళీ v naught by 4 తో పైకి వస్తుంది అనుకుందాం సో ఎవ్రీ టైమ్ మై వెలాసిటీ ఇస్ బికమింగ్ హాఫ్ let us say so vn velocity is vn minus 1 half of vn minus 1 first bounce లో rebound velocity half of headache సెకండ్ హెడ్ లో ఎంత v by 2 తో హీట్ అవుతుంది v by 4 తో rebound ఉంటుంది సెకండ్ bounce లో v by 4 తో హీట్ అవుతుంది v by 3 తో rebound ఉంటుంది so every time it's becoming half let us say right there could be some ratio 1 by 3 కూడా ఉండొచ్చు ఏదైనా ఉండొచ్చు for simplicity I've taken half let's plot a graph for this one so what is the probability of the graph now let us say upward is positive downward is negative this for the first to and fro motion so particle is going up at v naught by g it will stop moment engine reach down by 2 v naught by g ఇక్కడ it bounce అవుతుంది when it bounces it will be v naught this is minus v naught it will not bounce to v naught now it will bounce to v naught by 2 So my graph will again start from V0 by 2. Right? But the slope has to be same. You are agree with this? నేను ఇక్కడ ఒక ఏం కాకపోయింది పార్టికల్ ఇక్కడ ఎందుకు రాలేదు నీ గ్రాఫ్ ఇక్కడ ఎందుకు ఆగలేదు అఫ్కోర్స్ పార్టికల్ ఇక్కడ ఆగింది పార్టికల్ ఇక్కడ ఆగలేదు బట్ వై ఇస్ గ్రాఫ్ నాట్ టిల్ హియర్ వై నాట్ ఎక్స్టెండెడ్ టిల్ హియర్ ఇలా ఎందుకు లేదు బికాస్ if if it is rebounding with v by 2 it will reach 0 పైకి వెళ్తుంది v0 by 2 తో పైకి వెళ్తుంది ఆగిపోతుంది మళ్ళీ వచ్చినప్పుడు మళ్ళీ వెలాసిటీ v0 by 2 ఉంటుంది so velocity will be minus v0 by 2 when it reaches ground its velocity will be minus v0 by 2 you are agree the minus v0 దగ్గర రాదు కదా minus v0 దగ్గర ఆగిపోతుంది డాట్
Yes, sir.
when I hit it now at the second house where will it go does it go to here
No, sir. V not
where
by
will it go right so it will go to v0 by 4 are all the lines parallel ఉంటాయా
Yes, sir.
why do they have to be parallel I know you understood the point Bhavna but I wanted to mention it why do they have to be parallel ఎందుకు ఉంటాయి అన్ని లైన్స్ eventually zero అయిపోతుంది but at certain time t final time t it will become zero that final time t also will calculate later there is not numerical should be done but right now we are just doing graphical analysis as I told you physical analytical and graphical all three should go together so we have done physical and graphical analytical part is remaining alright when we do the Olympiad question tomorrow we'll discuss that but right now tell me this is that why it's parallel first parallel ఉంటాయా లేవా అదే everyone yeah Bhavna go ahead Ashmita Bhavna Ikra Omkar Umar Shravani who else is here these are the names I remember because these are students who are interacting and whoever is here Rosia is also here students if you miss one class you have to attend the recorded session and come back otherwise you'll miss the continuity fortunately that Saturday's classes independent ఆ AX graph VX graph ని యూజ్ చేయట్లేదు అది యూజ్ చేస్తే అది కూడా అర్థం కాదు ఇది అర్థం కాదు ఇది కంటిన్యూటీ యూజ్ అవుతుంది కదా అందుకే alright so why do the lines have to be parallel that's a question ఇంతకు ముందు చూస్తారు కదా lines were all parallel why were they parallel except that the instant of collision my acceleration is negative g throughout the motion so ఇక్కడ acceleration negative g ఇక్కడ కూడా acceleration negative g ఇక్కడ acceleration negative g negative g negative g negative g negative g negative g that means slope of all the lines have to be same slopes are same and the angle of inclination is also same it means they're all parallel you understood this point right
yes, sir.
then why didn't you say
Yes.
Bhavna why were you hesitant all right be confident you're all doing good Trust me, you're all doing good. This batch is really doing good. The only thing is, what I'm afraid is that people are not implementing DBPs. Vectors DBP pending on the class DBP pending on the you not have responded, and maximum you have DBP depending on the you have not responded. Alright, we have to do those DBPs. Prati DBP, మంచి DBPs ఉన్నాయి. We have to do complete those DBPs. Alright, okay, let's come back to this. So they have to be parallel, and they all decrease in width, and immediately tend to zero. కానీ గ్రోత్ షేప్ కన్నా జీరో అవుతుందా ప్రాక్టికల్లీ జీరో అవుతుంది బట్ నా మోడల్లో ఇది ఎందుకు ఎవ్రీ బౌన్స్ దగ్గర V0/2 అవుతుంది V/2 అవుతుంది మరి V/2 దగ్గర V/1 అవుతుంది V/8 అవుతుంది V/16 అవుతుంది సో బట్ ఇది not zero at least it's V/2 power n so it will be V0/2 power n. Alright, all those mathematics look into the data, don't worry about it. Okay, now then the interesting thing is the answer. Oh, by the way, this is previous exam question. The one which you just now saw it is a previous exam question.
Sir,
Now
I
let's look
can't
at one
understand that.
foot. Sorry,
I can't understand that problem, sir. Please.
this one?
Hmm. Now,
Oh,
now you last one, sir.
ఇదే కదా ఇప్పుడు బౌన్స్ అయింది
Yes, sir.
ఆల్రైట్ మరి చెప్పాలి కదా నేను ఇంతసేపు అడిగాను చెప్పాలి కదా ఓంకార్
Sorry, sir.
దట్స్ ఓకే డోంట్ హావ్ టు సారీ దట్స్ ఓకే సి వాట్ ఐ విల్ సే ఇస్ ఇనిషియల్ లాస్ ఇస్ V0 ఫస్ట్ బౌన్స్ దగ్గర -V0 అవుతుంది బట్ ఎవ్రీ బౌన్స్ దగ్గర ఏమన్నాను హాఫ్ ఆఫ్ ది బౌన్స్ ఇనిషియల్ లాస్ అవుతుంది V తో హిట్ అయితే V/2 తో రిబౌండ్ అవుతుంది V/2 తో హిట్ అయితే V/4 తో రిబౌండ్ అవుతుంది V/4 తో హిట్ అయితే V/8 తో రిబౌండ్ అవుతుంది V/8 తో హిట్ అయితే V/16 తో రిబౌండ్ అవుతుంది ఎవ్రీ టైం అయిపోతుంది లాస్ కరెక్ట్ ఆ లాస్ ఎక్కడ పోతుంది కైనెటిక్ ఎనర్జీ ఇస్ లాస్ట్ ఇన్ హీట్ ఆర్ సమ్ అదర్ ఫార్మ్ ఆఫ్ ఎనర్జీ కైనెటిక్ ఎనర్జీ లాస్ అవుతుందంటే వెలాసిటీ ఇస్ బీయింగ్ రిడ్యూస్డ్ స్పీడ్ కైనెటిక్ రిడ్యూస్ అయిందంటే స్పీడ్ టు రిడ్యూస్ అయిందంటే now after this bounce ఈ బౌన్స్ తర్వాత నా velocity will not be reaching this point ఈ గ్రాఫ్ ఉండదు this graph was for ideal case where the particle was bouncing up and down up and down up and down forever from the same height ఆ సేమ్ హైట్ వరకు వస్తుంది పార్టికల్ and it was bouncing forever without any loss of energy బట్ ఈ కేసులో ఏమవుతుంది బౌన్స్ తర్వాత V0 బౌన్స్ ముందు ఉంటే just after the bounce velocity is V0/2 ఇది -V0/2 వరకు వస్తుంది V0 just before bounce ఉంటే just after bounce V0/4 just after bounce V0/8 just after bounce V0/16 V0/32 that's how it goes. The important point was the graph has to be parallel. All the lines have to be parallel. Why does it have to be parallel? Because except at the instant of collision, except at the instant when it's bouncing, hit అయినప్పుడు దాని తప్ప ఆ ఇన్స్టెంట్ తప్ప my answer is energy throughout the motion. That's why the graph is linear. G is constant, negative G. ఇక్కడ కూడా నెగిటివ్ G ఉంది అంటే రెండు కంటిన్యూ ఉండాలి కదా నెగిటివ్ స్లోప్ సేమ్ ఉంది స్లోప్ సేమ్ ఉంటే యాంగిల్ మెయింటైన్ కానీ సేమ్ సో ఈ స్లోప్ అన్ని స్లోప్స్ ప్యారలల్ ఉండాలి సేమ్ ఉండాలి అంటే యాంగిల్ సేమ్ ఉండాలి అంటే లైన్స్ ప్యారలల్ ఉండాలి సో లైన్స్ in the graph if now I draw one line like this is graph now something wrong with you something wrong with an angle okay it's okay now it's quite clear.
Yes, sir. Thank you, sir.
Yeah that's okay so ఫస్ట్ లైన్ నేను ఎలా తెచ్చాను ఈక్వేషన్ తో తెచ్చాను సెకండ్ లైన్ ఎలా తెచ్చాను అనాలిసిస్ తో తెచ్చాను లాజికల్ అనాలిసిస్ తో తెచ్చాను ఈక్వేషన్ రాలేదు ఈక్వేషన్ కూడా రాద్దాం బట్ నాట్ నౌ బట్ నౌ లుక్ ఎట్ దిస్ కేస్ వాట్ ఐ డూ look at this case this is a very tricky case and I have only 8 minutes left, 8 or 9 minutes left. What I do, launch చేశాక V0 తో లాంచ్ చేస్తాను. ఇది ఈ హైట్ వరకు particle is leaving this side, right? But what I do, I keep suddenly after launching, I suddenly after this, I keep a wall here. I keep a roof here. Sorry, a roof here, such that it is not allowed to go to that height. And అక్కడ ఇది బౌండరీ మళ్ళీ కనిపించండి దీనికి ఆపాను మనం. What is that? The difference between this and before? In the previous case, the particle was going to rest momentarily at its highest point, peak point. It was going, stopping, and then coming back. But in this case, it's going, hitting, reversing the motion, hitting the ground, going up, hitting the roof, coming back, hitting the wall. So it's going up, going to smoothly at any amount of time. Right? That means my VT curve should not cross T axis. Velocity zero out like that.
No, sir.
So my VT curve should not cross the T axis. Do you all agree with that?
Yes, sir.
Now this is a very tricky situation. Please focus. I repeat again. One statement చెప్తాను. But it's very tricky situation. నేను one collision, two collision వరకు చెప్తాను. మీకు గ్రాఫ్ పెద్దగా ఇస్తాను. And that goes on forever. There is no loss of energy anywhere. Alright? There is no loss of energy. So this V0 goes up at this point, let's say some height దగ్గర V0 prime ఉంది అనుకుందాం. ఇక్కడ velocity V0 prime ఉంది అనుకుందాం. See, we do analytical analysis later. Graphical analysis చేస్తున్నాం మనం. And physical analysis రెండింటికి correspond చేస్తున్నాం. If you understand these two, and analytical is very easy. The mathematical part is very easy. This is tricky. Look at this. Right after this one, just before this, it is V0 prime upward. Right? ఇక్కడ V0 prime upward ఉంది. Right after this, V0 prime downward ఉంది. So velocity is suddenly jumping to negative. Minus V0 prime. You are agree? దీని తర్వాత గ్రాఫ్ ఎలా ఉంటుంది? I'll draw two options. ఇలా ఉంటుందా? ఇలా ఉంటుందా? Upward or downward?
Downward, sir.
Downward. Why downward? Both of you have pulled downward. Why? That's correct. But why?
V0 dash velocity తోనే ఉంటుంది సార్ ఇది కూడా.
V0 dash తో వస్తుంది కిందకి. మళ్ళీ కిందకి వచ్చినప్పుడు ఇంకా స్పీడ్ పెరుగుతుంది. కిందకి హిట్ అయినప్పుడు ఏ వెలాసిటీ వరకు వస్తుంది? మైనస్ V0 వరకు వస్తుంది. V0 right? Collision sudden V0 right to V0. What is V0? So ఇక్కడ చూడండి, these two lines have to be parallel or not?
Yes, sir.
Why do they have to be parallel?
Slopes.
Acceleration is same.
Exactly. Others. See, from this you are getting the idea. You are not able to express it. That's it. Okay. But express it. That's okay. No one is here to judge you. Everyone is a learner here, and I'm here to encourage you. Alright? ఏ థాట్ వచ్చినా చెప్పండి. ఆ థాట్ ని కరెక్ట్ చేస్తాను, విల్ గో అహెడ్. థాట్ ని కరెక్ట్ ఉంటే అప్రిషియేట్ చేస్తాను, రాంగ్ ఉంటే కరెక్ట్ చేస్తాను, అంతే. బట్ నో వన్ విల్ డిస్కరేజ్ యూ హియర్. రైట్? No one will ever discourage you in this organization, I'm telling you. All right. Now look at this. It goes from V naught to V naught. It can go from the
ఏంటి సార్?
ఈ పాయింట్ దగ్గర ఏమవుతుంది? ఇది ఏ పాయింట్ ఇది? మైనస్ V
Sudden
naught.
V0.
ఏంటి?
Sudden jump to V0 sir.
సడన్ గా V naught. ఎందుకు అది గ్రౌండ్ దగ్గర అవుతుంది? ప్రూఫ్ దగ్గర అవుతుందా? గ్రౌండ్ దగ్గర అవుతుంది, ప్రూఫ్ దగ్గర అవుతుందా? సడన్ జంప్ V naught ఇస్ వెరీ కరెక్ట్. ఇక్కడ సడన్ జంప్ అవుతుంది. So ground. This is roof. This is origin roof. Is it origin roof? Origin ground. And all these lines have to be parallel. All right. You agree with that? All these lines have to be parallel.
Yes sir.
तो बोलो भाई say yes or no, हाँ ना कुछ भी.
Yes
Yes,
sir.
sir.
हाँ ठीक है. Okay. Thank you. हाँ. So the point is next again this roof particular ground. మళ్ళీ V naught వెళ్తుంది. మళ్ళీ V naught కి వస్తుంది. తగ్గుతుంది. మళ్ళీ కొలిషన్ అవుతుంది. మళ్ళీ V naught కి వస్తుంది. మళ్ళీ V naught వెళ్తుంది. మళ్ళీ కొలిషన్ అవుతుంది. So that goes on repeating. Now look at this. If I move this closer to ground, ఈ గ్రాఫ్ ఏమవుతుంది? షేక్ అవుతుంది. ఎక్కువ కొలిషన్ అయిపోతుంది. Right? If I move this through further away from ground, right, పెరిగితే what will happen to the graph? Graph will extend. If this roof is above this level, so there will be no collision with the roof. So ఈ collision vanish అయిపోతుంది. Collision with the roof will vanish. And this will cut the x-axis like this. Same as previous graph. ఇది అర్థమైందా అందరికి?
No, sir.
Okay. Okay. Listen. So this is the graph for this level. అదే నేను ఇక్కడ రూప్ పెట్టాను అనుకోండి. రూప్ పెట్టాను. ఇది ఫస్ట్ కేస్, ఇది సెకండ్ కేస్, ఇది థర్డ్ కేస్. ఈ 3 కేసెస్ లో గ్రాఫ్స్ ఎలా ఉంటాయి చూస్తున్నాను. ఫస్ట్ కేస్ లో ఇది గ్రాఫ్. సెకండ్ కేస్ లో ఏమవుతుంది గ్రాఫ్? ఇఫ్ ఐ మూవ్ ఇట్ క్లోజర్ టు ద గ్రౌండ్, దట్ విల్ హిట్ ఫాస్టర్ అండ్ కమ్ బ్యాక్. అంటే వెలాసిటీ ఇక్కడ రైట్ అవుతుంది. సమ్వేర్ బిఫోర్ దిస్ ఇట్సెల్ఫ్. ఇక్కడ నుండి ఇప్పుడు వచ్చి మళ్ళీ V naught వస్తుంది. Should shrink like this. This will length will reduce. And they will parallel but shrink. So okay, is the point okay? Is the point clear? Omkar, is it clear?
Yes, sir.
ఇప్పుడు third case లో ఏమవుతుంది? When the roof is above this level, that is this particle is not at all hitting the roof. అంటే ఈ పాయింట్ డిసపియర్ అయిపోవాలి. ఏ పాయింట్? ఈ పాయింట్. రూఫ్ కొలిషన్ పాయింట్ డిసపియర్ అయిపోవాలి. రూఫ్ కొలిషన్ డిసపియర్ అయిపోవాలి. డిసపియర్ అయిపోయి ఏం రావాలి? వీడి ఎందుకు? Because one is going to stopping for a moment, coming back. That stopping for a moment has to be seen in the graph. ఎందుకు వస్తుంది? will disappear. And this line will come till here. As the previous case, particles going up and down forever without any roof. Alright?
Yes, sir.
Yes, sir.
So students, guidance for today is you have to plot this graph, think through the graph, show the same would the so why the graph and what you can give if I what happens to the graph effect, we have to plot here. To it. As a 10 minutes exercise, 10 minutes అయిపోతుంది అన్ని త్రీ టాపిక్స్ డిస్కస్ చేశాను వన్ ఇస్ గోయింగ్ అప్ అండ్ డౌన్ ది అదర్ ఇలా 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 మళ్ళీ తగ్గుతూ వెళ్తుంటే థర్డ్ గ్రాఫ్ తీసుకోవాలి collisions. So whenever there is a collision, there is a certain summation velocity. The collision part we'll discuss later. Collision అప్పుడు ఏమవుతుంది we'll discuss later. But right now at collision what we know is there is certain summation velocity. So we can think so. You do it on a paper. Rough sketch చేసేయండి. Okay? But think all the points. Physical analysis తో rough analysis రెండింటికి correspond చేయండి. Right? Will you all do it?
Yes, sir.
Others, will you all do it, please? Omkar, Ifra, Ashita.
Yes, sir.
Oh, Ifra is so
Yes.
dull. Ifra
Yes,
is
sir.
okay. Alright, so students, please do the 10-minute break. We'll join in the next class, either in the evening or tomorrow morning. We'll continue with analytical analysis. We are not written any questions for the lines. Then we'll enter into some problems under gravity and constant acceleration and variable acceleration. And then AX and VX I'll repeat. Alright. AX and VX I'll repeat. There are certain points which I haven't mentioned deliberately, and those points I'll repeat when I repeat the graph. AX and VX, that's very important. From advanced point of view, that's very important. From Neet point of view, VX graph is very important. Alright. Alright, students, thank you all. Bye everyone. Have a great day. You have a chemistry class coming up. Madam is already waiting there. Thank you all, students. Thank you, ma'am.
Yes, sir. Thank you, sir. Yes, students, you can join the next session. That is from 6 to 7.